Okay, so for chemical bonding, we split the topic into two segments. One is ionic compounds. Okay, ionic compounds. Then we have the covalent ones over here. All right.
So it's not behaviors.
All right, hang on.
There we go.
Okay. Now let's talk about ionic first. How is ionic compounds formed? How are they formed?
The metal with metal.
So the metals are the positive ions, and you have one. The other one has to be a non-metal.
So it's basically cat ion and
Yeah, correct. Cations and anions. Okay, so I give you the example. Let's take a look. The best is to really try things out. So let's have magnesium fluoride. Ionic or covalent? Ionic. So what's the metal? Which side is the? So this is the positive.
Fluoride is the gas.
Fluorine is a gas. This is the ion.
Oh, fluoride is the ion of fluorine.
Fluoride
Uh-huh.
is the ion.
Okay.
Okay, now that Samuel mentioned something, it's important to bring this out. Fluorine is a gas.
Fluorine is the gas and it's an element.
Fluorine is a gas that kills people.
Then why is it in
poisonous
toothpaste?
gas.
Then why is it in toothpaste?
Exactly, because fluorine is not in toothpaste. Fluoride is in toothpaste.
Oh.
Fluorine is a gas that kills people.
Okay.
Or rather, you know, there's a lot of history with fluorine gas.
So does that mean if like I eat toothpaste, I will like have cancer?
No, because it's fluoride that's in toothpaste.
Well, if you eat too much of toothpaste, you're gonna have a bad time.
Huh?
With your
What do
stomach.
you mean?
Toothpaste is not meant to be eaten.
Okay, so it goes down the system and what
Unless
happens?
it says edible toothpaste.
Huh? There's such a thing.
Yeah.
What?
Oh,
Anyway, what is magnesium fluoride? Ionic or covalent? So I hope you guys can understand about it. Fluoride. Okay. That is an ion. Fluorine is actually a gas molecule. It's a gas. Fluorine kills. Fluoride, yeah, still fine.
Wait, fluorine and fluoride are related.
Yes, how are they related?
One is an ion, the other is an element.
Correct. Fluorine is in its elemental form. Extremely reactive.
Reactive.
Yeah. Okay.
Actually, where can we find fluorine in daily life?
Probably not anywhere else. Industries, factories, when they are doing chemicals, pharmaceutical companies, the plants and all that, they have like giant gas tanks that go through the pipes, and they usually use the chemicals to mix to have the reactions, to give you the products that you need.
Oh.
Yeah. So it's like a conveyor belt system, except that it's through the pipes.
I see.
Yeah. Anyway, can someone tell me about their structure? So your homework has something called structure that you're supposed to fill in. Can someone tell me about the structure?
Structure is in the electronic configuration.
No. Structure in terms of the whole compound. What kind of structure do they exist in?
The matrix. Wait, no, that's a Covalent.
Everything is Mickey Mouse to you, huh?
No. So it's the other one. It's the one with square brackets.
So I give you the first word. It's called giant
Giant lattice structure.
lattice structure. Yeah. Okay. This is what they mean by structure. In this case, it's not a giant lattice, giant ionic lattice structure. If it's ionic, it's definitely a lattice structure. Okay. What does the word giant mean?
Big.
Big. In this case, it means never ending.
Never ending.
Never ending. It goes on forever until you reach the end.
For example.
That means to say that the pattern repeats itself. So you will see things like this, like a cube. Okay, this is where you see a cube.
Is all of this real or is this just simplified?
Well, it depends. Depends on the model you're looking at.
So,
If you're looking at a very you're looking at a classical model, yeah, this is real. This is what you have. But if you're looking at quantum model, it goes beyond this. But this is the one that makes the most sense to students of your age.
Okay.
And that's why you're learning this. So think of this as a cube. The dot dot here represents never ending. A cube with dot 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 dot. That means the cube continue until you run out of the ions. Then it stops. So which means to say that the structure repeats itself again. The word lattice means that the pattern continues. The pattern continues. It's like copy and paste, copy and paste, copy and paste. Right? Can someone tell me about these lines here? All right. Okay, so you can have your positive ions and your negative ions connected to each other. Can someone tell me about this line here? What does this represent?
What line?
The line between the positive ion and the negative ion.
Strong electrostatic bonds.
Yes, correct. Strong electrostatic forces
of
of
attraction.
attraction. Okay. So this is a keyword that you will need to include when it comes to answering the melting point, boiling point questions. Okay, this one, because it's strong, right? Does it require little energy or a lot of energy?
A lot.
Okay, require a lot of energy to overcome. Hence, what can we say about the melting point and boiling point?
High.
High
I'm melting
melting
point.
point. How high are we talking about?
In the thousands, potentially.
Yeah, the thousands.
1,000 degrees to 3,000 degrees.
Do I have to know that?
You don't have to know that, but it's interesting lah. The question is, how do we make this happen?
I don't know, send it to the sun.
No, the sun is way hotter than that. You need a furnace. You need a furnace for this. Basically, you can make a small furnace by using a clay oven. So if everything is made of clay,
like a kiln.
Is it like the one where you like put the pizza inside the food?
put a what?
The pizza inside the food.
Yeah.
Basically that.
That means this will take how long to like?
It will take a while. It will take a while. The clay itself is a good insulator of heat. So it keeps all the heat inside there. So you make a clay, you can basically make a hollow cylinder with the material being clay, and then you put your, in this case, magnesium
Fluoride
inside, MgF2. And you just put the fire below, you cover it up with a lid, keep all the heat inside. The heat will build up, temperature will increase, and you can heat your 1,000 to 3,000 degrees.
And then what? Come back the next day.
You can try and see how it goes.
I probably would have an explosion by the time we come back.
If you don't add anything to it, it will just stay in what it is, which is an open form.
Okay.
But if you do add something to it, you get an explosion.
Okay.
And there are videos on that.
What do I add?
We shall find out later on.
Oh, no sodium.
Okay, so it's important to take note about this. Okay, other things to take note: metals are givers, non-metals are takers or receivers. Okay, you have the very generous people, and you have the very greedy people. All right. So you must know all of this. You must know what's a metal, what's a non-metal. Okay, identify based on their compound name. So what was the question that I was giving you just now, Gabriel? Is it magnesium oxide or what?
Sodium oxide.
So the one about the melting point.
Yeah.
Okay. So you understand how to answer that?
Yeah.
So these are keywords, Let me highlight to you, All these are keywords, Right. So do take note of that, because you will be required to put these keywords into your answers. Are we good? Okay, let's go on to.
Wait, I don't highlight.
All right. How fast can I erase this? That's the question.
You can do the countdown thing,
Count now.
like the 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, whatever.
Okay, 5.
No, from 10.
Just
Please.
just copy it down. It's fine.
I don't know, you say you want to time me.
Nah. I time you when you're doing your mock
I'm
test. Okay. I'm not going to time you for copying down stuff. It's more like how fast can I erase this?
Yeah, the timer's at 15 seconds.
What timer?
This timer.
Ooh. So I would recommend that you guys, after you watch the video, after you finish reading through this, come out your own cheat sheet that looks something like this.
I'm supposed to make a cheat sheet for myself
There you go.
and bring it to an exam.
So you use this opportunity. Okay. All right. Let's use a different color. Covalent compounds. Now, covalent compounds can be separated into two different types. We have the simple covalent molecules. And I'm just going to put it on the other side. The other one is what?
Giant covalent structure.
Giant covalent structure. So how do we identify simple covalent molecules? Usually it's with a non-metal and another
non-metal and a non-metal.
So two receivers, two takers who are too greedy will have no choice but to share. Yeah. Because if I can do nothing else but take, and you can do nothing else but take, and there are only two of us here,
Then what?
we have to share.
Okay.
We have to share.
So basically you're forcing them to share electrons, huh?
They have no choice but to share. It's a sharing of electrons. Okay, the most common simple covalent molecule will be, what is that? The most simple
Water.
covalent molecule. Yes, the water.
Wait,
So
really?
Yeah. Why do you think people
As
draw
in-
H2O? It's like
most common lah. Most common simple covalent molecules. Water. So water can be drawn as this. Now, can you tell me, is the oxygen a metal or non-metal?
non-metal.
Yeah, it's non-metal,
But so is hydrogen.
and so is hydrogen.
And therefore H2O is a covalent compound, and that's why H2O2 is also a covalent compound. Right?
Yeah. H2O2 and H2O are very much different things. H2O, once again,
One kills one.
H2O2 can kill you if you drink too much of it. H2O doesn't kill you unless you drink a lot.
Apparently you can get water poisoning.
Yeah, but that takes
A lot of water.
a lot of determination.
ES is electrons, right?
Yeah, E
I
negative.
put
S.
E negative.
Yeah, E negative S is electrons.
Wait, so H2O2 is what?
Hydrogen peroxide.
Hydrogen peroxide.
Yeah.
Isn't that the thing they use to freeze off certain things?
No,
That's nitrogen.
that's nitrogen.
Well, even then, nitrogen is cold.
Okay, so how it goes is this. You have each group of H2O, right? Each group here. Let me use another, okay, I'll use a black one. Each group here, is what they call a molecule. Okay, the black ones, the one I circle in black, is one molecule. Molecule number one, molecule number two. Okay. Now, within the molecules, you have very strong covalent bonds. These are covalent bonds. Okay, you see the line here, that's a sharing electron, you have covalent bonds. If you are not sure what the line means, let's draw a quick dot cross diagram, which by the way, Samuel, you need to work on that. Huh?
Mhm.
The dot cross diagram needs work. Okay. So you have dot and cross like this. So when I draw a single line here, it represents a single pair of shared electrons, a pair. A dot and cross represents a line, or a dot and cross is represented by a line. So I have one O with two lines going out to one H each. Means that that's a single pair of electron being shared. These are strong, very strong covalent bonds. Okay, it takes a lot to break them apart. Okay, but nonetheless, yes, you have to use electrolysis. Nonetheless, they can be broken down. So Samuel, in your mock test that I just marked as now, they can be broken down. So it's wrong for you to say they can never be broken down. They can be broken down, but it takes a lot of energy to break it down. Covalent bonds, very strong, very difficult to break, very difficult to overcome, but it can be done. Okay, so I'm going to put here, these are strong. So remember, Gabriel, yesterday I mentioned to you the squiggly lines. I asked you to draw that. Yeah. So draw squiggly lines in between the two molecules. And you have what they call intermolecular forces of attraction. Some may call it van der Waals. It's fine, whichever term is okay.
Oh, that's the name of the thing.
Yeah.
Oh, that's what van der Waals is.
Yeah. You can use intermolecular forces of attraction. So that's fine. These are weak. Okay, so let's put it down here. Weak WEAK. Okay, weak intermolecular forces of attraction.
How to spell Bangalore, so
You don't have to refer to your notes. Just stick to intermolecular forces of attraction. So these are weak. Okay, if they are weak, do you need a lot of or very little energy to overcome? So let's put it here. Requires little energy to overcome. So what can we say about their melting point and boiling point?
So
Okay, who can now chemistry is important in terms of identifying the substances. Who can tell me what are other examples of simple covalent molecules?
Carbon dioxide,
Okay, carbon dioxide is one.
carbon monoxide,
Sure.
dihydrogen oxide.
That's
Wait,
just
that's water.
any others? What about sulfur? Anything about sulfur?
Sulfuric acid. Right?
sulfur dioxide.
Sulfur dioxide.
Well, what about sulfuric acid?
What about it?
Is it a covalent compound?
What do you guys think?
Sulfuric
It's metal and
acid.
non. It's metal and non-metal.
Oh.
Metal, non and non. So it's covalent.
Okay, sulfuric acid is a very unique substance. It has both ionic and covalent bonds inside.
What?
Yeah, but let's not talk about it in this lesson.
Okay.
Otherwise, you will
It's
be
gonna confuse.
confused.
Okay, hydrochloric acid.
I'm gonna help you lah. If you are thinking about hydrochloric acid, you can use hydrogen chloride, which is also a covalent molecule.
Oh, okay.
Okay,
Okay,
so
what's
all
the
these,
difference between HCl acid and HCl not acid?
one is a gas and the other one is dissolved in water.
So if I dissolve HCl not acid in water, I have HCl acid.
Yeah. And before you ask, that's another topic for another time. You'll be very confused if I will talk about it now.
Okay,
You
fine.
might probably need another master bar for that, maybe two more.
Oh,
So let's not go there. Um, any others? Any other? What about this? Can anyone tell me what is this? CH4.
Carbon hydroxide.
This is good try. This is
Oh,
called methane.
this what?
methane.
Methane is the most common
Gas.
you can find it under natural gas.
It's oil,
Okay,
isn't it?
you can find it in the exhaust pipe of many animals in the world.
Animals or cars?
Exhaust pipe of cars as well, both man-made and biological.
Great.
Okay, methane can exist as an unburned hydrocarbon in cars, combustion, or it can exist in the exhaust pipes of animals, if you get what I'm saying.
Yes, I understand.
Yeah.
Yeah.
Methane is the second major greenhouse gas in the world.
Okay, I can only assume it's because of cars.
The first is carbon dioxide.
Okay.
No, it's not cars. It's basically beef, cows.
Cows?
What, livestock.
What do they have to do? They're natural.
Because everyone needs to eat pork and beef, right?
Mm-hmm.
Yeah, so the farm animals have to be alive before they can be consumed. And while they're alive, they have exhaust pipes.
Uh-huh.
There you go. Get it?
So you're saying that we should try lab grown beef.
Oh yeah, I mean the first lab-grown meat was approved in Singapore. I think they're running some tests on it.
So you're saying that any
Lab-grown meat is coming actually. It's like the future.
yeah,
Yeah.
I think there's like vegan meat or something.
that's
Yeah.
another option.
Yeah, that's another option.
Yeah.
Lab-grown.
Yeah. Like, how do they do it though? It's so interesting.
Basically it's just mushroom and tofu lah. If you want to go for vegan.
Yeah.
Anyway, coming back to this, okay, that's why we have low melting point, boiling point. All these are common examples. I'm sure there are more. Please do more questions. Get used to it. If you are doing a cheat sheet, right, you should add more to it so the list can go on. All right, I'm just going to put down here. Dot, 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 etc., etc. The list can go on.
But actually, can I ask you,
Yes.
is carbon hydroxide? Is there such a thing?
CH2.
No. There are different variations of carbon. You have carbonic acid, you have carbon dioxide. Carbon hydroxide,
Graphite.
it's not. To get a hydroxide, you need basically a metal. Example, sodium hydroxide.
That's sodium.
I know, correct, but if technically, right, you do a cross method of carbon and hydrogen, you
Yeah.
actually get CH4. Oh wait, no, you don't. Sorry, no, it's 2 plus.
If you get a CH4, then it's methane.
Yeah,
That's the name. It wouldn't be called carbon hydroxide.
that's why I'm confused.
Okay, let me, if you're confused, let me just clarify this for you. And the next time you're confused, watch this video again. Hydroxide is a combination of two elements, hydrogen and oxide. So when you say hydroxide, right, you're dealing with hydrogen and oxygen. So CH4, does it have any oxygen?
No.
So it cannot be a hydroxide. Okay, the word hydroxide represents the ion OH minus. All right, that is what they call a polyatomic ion. And that's something for subsequent chapters.
Oh wait, what? I'm gonna have to learn that?
Yes, everyone learns that. This is alkaline. Okay, this is the ion responsible for
Hydroxide is always an alkaline.
for
Yeah.
alkaline substances.
So,
Alright.
lithium ion.
So when you say CH4, right, that is not a hydroxide.
Yeah.
CH4 is methane.
CH4 methane.
Wait, then what about ethanol? Is that a covalent compound?
Yes, it is.
Okay. What about petroleum? Or no, petroleum is a mixture.
It's a mixture of covalent compounds.
Well, what's inside petrol?
Alkanes and alkenes, hydrocarbons.
Okay.
That's something for later on.
Wait, later chapters or later in my life?
Sec 4. Sec
Oh,
4.
great. I also got to study nuclear radiation.
Yeah, isn't secondary school fun?
I get to play with questionable substances in the lab, hopefully.
You probably not, but we can only hope. Yeah.
What's the legalities of doing that anyway?
That is something not to be discussed in this YouTube video that we have here. All right. That's all we have for simple covalent molecules. Now, if you want to understand the keywords, sharing of electrons, strong covalent bonds, weak intermolecular forces of attraction, these are keywords to take note. Require little energy to overcome, low melting point, boiling point. All right. Simple covalent molecules. Yeah, there we go. So with this, you can answer that question that I texted you in the chat group. Like, why does sodium oxide have a higher melting point, boiling point compared to water? Okay, so you have to mention in terms of the type of compound, simple covalent molecules, and things like the structure and the forces of attraction what we're dealing with. So it's important to take note that when we boil something or when we heat something, we are breaking this bond, intermolecular forces of attraction. When we are boiling something or when we are melting something, we are overcoming this.
And it's the
We that none of these covalent bonds will be involved during a state change. Okay?
So how do I break hydrogen and oxygen? And how do I break H2O and H2O2 into its constituent elements?
H2O2 can be easily broken down.
Easily.
Basically, there are many different videos online. They talk about making elephant toothpaste where you put something inside and then it just balloons up, and then you get a long tube of colored substances that comes out.
Yep.
They call it elephant toothpaste. That is the breaking down of H2O2.
Seriously?
Yeah.
Man, Mr. Beast, like, did the
You-
most, just
Yeah.
toothpaste experiment.
You add like a catalyst to H2O2, it just breaks down by itself.
A catalyst being what? Wait, what's the definition of catalyst?
That's something for another time. Stay tuned for my videos.
So basically, X plus H2O2 equals an acidic explosion that might get me.
No, H2O2 itself can be broken down.
Okay.
So basically, the catalyst simply causes it to break down faster. So there's no X plus H2O2. It's just H2O2 giving you H2O and O2.
Oh, okay.
Yeah.
Oh yeah, I saw someone playing it in the movie, the catalyst. After that, they added it to some substance, and then it ended up like bubbling the whole house.
Yeah, that's possible if you have enough. There is like a YouTube video about Guinness World Record, like breaking the Guinness World Record for the largest amount of elephant toothpaste that can be formed in a single session and things like that.
Yeah, Mr. Beast had a whole house of H2O2.
Okay.
It was too funny, and then the father had to clear up the mess, and then after that they didn't flush it. Then someone go and pour in the toilet bowl. After that, the toilet bowl also ended up like
It's
like-
kind of a waste, like if you ask me.
It's like,
Resources and
oh
things
my
like that. Yeah.
Actually, what happens if I pour H2O2 down the toilet?
Nothing happens.
Okay.
Yeah.
But what about breaking
By
down?
itself, it takes some time to break down, so nothing really happens. If you add a catalyst, it will break down in an instant, and that's where a lot of things will happen.
Oh, a catalyst is basically like the Mentos and the Coke and Mentos thing, right?
No, not that. A catalyst is something that accelerates the reaction
Oh.
without being involved in it.
So basically, like a catalyst is something that makes us fly faster.
A bit morbid way to describe, but okay, sure. You can see that way.
Then how
Yeah.
do you, then how do you,
Moving forward,
how do you break down H2O?
the short answer is electrolysis.
Uh-huh.
Something that you will never learn because you're in combined science, but you will learn about that because you're in pure chem. Till next time for a video on that. All right, the next one is giant covalent molecule or giant covalent structure.
Wait, do I have to
Okay.
learn giant covalent?
You don't, but it's interesting to take note.
Okay.
No, do not touch your phone. I know what you're thinking. Don't go there, or I will confiscate your phone.
Yes, the giant covalent molecules is not a billion Mickey Mouse. It's not a lot of Mickey Mouses coming together, right?
No, it's not.
Oh.
Okay, so here's the thing. Giant covalent molecule may not be in your syllabus, but sometimes I've seen it in the school papers where it is the last question and it's a database question.
Database.
So basically they give you a whole ton of information about giant covalent structures, and then they'll ask questions about it. So you may not have learned about it, but sometimes you may be given a question where you're supposed to do a bit of learning on the spot.
Ah,
Yeah.
okay, right.
So there is a chance that it may come out. But if it does, you'll be given a lot of information about it. So here we go, giant covalent structures. This is quite interesting. What are giant covalent structures? So basically, for example, if you have a carbon here, if this dot is a carbon, and you have 4 other carbons surrounding this carbon.
This diamond, right?
Yeah, they will share electrons with each other like so. And then you have a structure like this called a tetrahedral
Oh, that's the one. That's what it means.
structure. Now, why is it called tetra? Is because there are 4 bonds for each lattice. So that's why it's called tetra. Tetra in chemistry is 4. Okay?
Tetrahedral structure.
Yeah. So this is the structure of diamond. Okay, so you can get used to drawing the tetrahedral structure of diamond if you want to. Basically, just make sure 1 carbon is bonded to 4 carbon atoms.
What's the list I need to draw?
Whatever that I've drawn here right now. It's fine.
Ah, really?
Yeah, just gotta make sure that the structure repeats itself. And then you draw a dot 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 to tell you that it is never ending or repeated. Okay, Samuel, anything you can tell me about diamonds? What do you know about diamonds, man?
They are hard.
They are not only hard, but they're the hardest.
Well, they
One
are
of the
the
hardest
hardest.
metals on
And
Earth.
The metals.
Metal,
Oh, metal.
M-A-T-T.
Uh,
Are diamonds expensive?
Cost lah.
in theory, they're not supposed to be. They're supposed to be common. It's just that there's one guy who has a monopoly on the market.
Diamonds, basically, diamonds have very little resale value compared to gold. If you buy gold and you sell it again, you can earn money
Yeah, I know
if the
some
price
people
goes
do
up.
that,
But if you buy diamonds and sell it again, maybe you get like a quarter or half the price. Diamonds can be found naturally.
Mhm. You can also lab grow
You
them.
get lab-grown diamond.
No wonder.
Yeah. They use the carbon vapor to slowly grow the diamond
Vapor?
in the chamber itself.
Mm.
It's pretty interesting.
Then what can I have lab grown gold?
Or you could try.
That would be kind of weird though.
You could be the first one to think about that.
Man, I'm interested in this. I'm interested in mechanical engineering.
You could come out with a mechanical machine to make lab-grown gold.
You earn a lot
Wait, no,
of
because
money.
That'd be
I
interesting.
probably would. And then I technically have a lot of gold, and then gold will be worthless.
Yeah. Anyway, can someone tell me about these lines? What are they? What are the lines? What do they represent?
The bonds.
What kind of bonds?
Strong bond. Covalent
And the
bond.
molecular.
Strong covalent bonds. Is there anything about intermolecular here?
Wait, no.
So here's the thing, if you got something that is giant, right? If the keyword is giant,
Mhm.
there is no intermolecular.
Oh,
Okay,
so,
intermolecular refers to simple molecules.
okay. So the diamond is the molecule.
The diamond is the one molecule. It's one giant piece of carbon atoms chemically combined here.
So if I have one diamond, if I have one diamond the size of my pinky, then that one diamond the size of my pinky is one molecule.
You can see it as that. Yeah. That's what it means by giant. Because it's one piece by itself. Okay, so these are strong covalent bonds. Now, do you see any intermolecular forces of attraction here?
There is no molecule.
There is no molecule, you're right.
Therefore, there is
There
no
is only one
intermolecule.
molecule. There's no like intermolecules. So you don't really see any IMFOA or BDW over here. It's just strong covalent bonds. Now, can you tell me about the energy required to break these bonds? Is it a lot or very little?
Ridiculously a lot.
Yeah, requires a lot of energy to break.
How would you break it down? Actually?
You probably will have to increase the temperature to weaken it first.
So
and then
first
use the second harder material to break it.
except the diamond is the hardest material, so there's no second hardest material.
But in its weakened form,
There's
it's not so
something that.
hard. Yeah.
Oh, okay.
requires a lot of energy to break. So what can we say about its melting point and boiling point?
High.
High melting point slash boiling point. Okay, and that explains why it's very hard. So you can use diamond to cut metals. They are called diamond saw or diamond cutter.
One diamond can make possible.
Yeah. All right. What is the other allotrope? Let's bring in allotrope. What is the other allotrope of carbon, which you are supposed to know?
Graphite.
Graphite.
I'm supposed to know or that where B has to know.
Gabriel is supposed to know.
Yeah.
What are allotropes, Gabriel?
Oh, the search of the meaning. Electrodes, right?
Allotropes are what?
Wait, is this right?
Different
No.
forms of the same element with different structural arrangements of atoms.
Yeah. Same elements. I'm going to put S there in different structure.
So does that mean wait, the diamond is also a allotrope?
Diamond is an allotrope. Okay, diamond and graphites are allotropes
Only this
of
one.
carbon, but there's more.
Oh.
I think carbon has about 60 different allotropes. I can't remember the exact number, but there are different forms. In your syllabus, the two most common forms will be graphite and diamond. Okay, so graphite itself is a single carbon bonded with 3 other carbon atoms, and you will get something like a hexagonal structure, right? That repeats itself. Okay, now here's an important thing to take note. Over here, you have 1, 2, 3, 4. You have 4 bonds. But over here, you have 1, 2, and 3. So because of this, you are left with 1 extra electron that becomes delocalized. So meaning to say each carbon produces 1 delocalized electron. Now, what's the significance of this? The delocalized electron allows graphite to conduct electricity. Okay, it allows graphite. I'm running out of space. Well, let's take this here. Allows graphite to conduct electricity. Okay. Oh, we're running out of time. 4 more minutes. I think. Oh, one more thing. So let's finish this. So each layer has weak van der Waals forces of attraction in between. So meaning to say you have a hexagonal layer here. So this is 1 hex layer. You have another hex layer here. So a line here represents a hex layer, and you have like all the wiggly lines here representing the VDW. And this is why you can draw with graphite.
I can what?
Draw. You can write with graphite because
Oh.
graphite is your pencil. Graphite is a pencil lead. So this weak van der Waals forces of attraction allows the layers to slide over each other easily. Oh, I'm running out of space, man. Okay, and this explains why you can write with graphite, which is found in your pencil. Okay, so this is a quick, simple overview on chemical bonding with all the relevant structures that we talk about. There is another type which is metallic bonding. You did a little bit of that in your worksheet. So we'll talk about that in the next lesson. But these are the ones that are common over here. Okay? Any question? I see Samuel is enjoying himself already in another land. Any question? KR?
No.